Welcome to the week 5 live lecture for college algebra. My name is Dr. Marissa May, and this week we're going to be taking a look at systems of equations. Now you may be asking, what are systems of equations? And I'm so glad you asked. A system of equation is either two or more equations. Now for our purposes, we're going to focus the first part of our time together on 2 equations. I'm going to do an example of 3 equations just to kind of give you an idea of what that looks like. When we look at the different methods of solving a system of equations, the one thing to remember is that the solution is where the 2 graphs intersect. No matter if you're dealing with 2 lines or 2 parabolas or 3 lines, you want to make sure you're looking for where those lines or those graphs intersect. Now, our solution of 2 equations can have one solution, no solutions, or infinitely many solutions. You may be thinking, like, how can that be? Well, let me show you. We're going to start with our very first method, which is the graphing method. I want us to look at these 2 equations, 2x minus y equals 8 and x plus y equals 1. I'm going to be using the Desmos graphing calculator because it's a free online calculator for you. If you need it, check the description below. I've left a link for you that you can access it. So let's take a look at that Desmos calculator. Now, when you come to the Desmos calculator, it's a pretty intuitive process to use. So I'm going to type the equations over here on the left, and Desmos will automatically graph it. Let me show you what I mean by that. 2x minus y equals 8. It's our first equation. Notice Desmos graphed it in red. And then to ask Desmos to graph the second one, I'm just going to click right here by the second line, and that's x plus y equals 1. And you'll notice that Desmos graphed this one as well, but this time in blue. Now remember, we said that the solution is where these 2 intersect. Now you can see it right here, but you'll have to take your mouse and hover over it, and Desmos will tell you the answer. Notice it's an ordered pair. So the solution here would be 3, -2. Like I said, Desmos is a very powerful tool. I want you to take advantage of using it, and I'll leave the link below for you. Let's take a look at one more system of equations. I've got x minus 3y equals 6 and x minus 3y equals -3. I want to see what these look like on Desmos to find our solution. All right, let's type in our equations. X minus 3y equals 6 and x minus 3y equals -3. So you've got a red and a blue line. Notice that they are parallel. And what do we know about parallel lines? They don't touch. That's right. So this is an example of where we have no solution. If the solution is where the lines intersect and they don't intersect, then we have no solution here. So I want you to use this Desmos tool to help you check your solutions. It's a very powerful tool. We're going to talk about 2 other methods, though, that I think are going to help you when you're solving a system of 2 equations. But before we jump into those 2 methods, I want to do just a quick way for you to check to see if an ordered pair is a solution to a system. So you see my 2 equations, the -3x plus 2y equals -4 and x plus y equals 3. I'm wondering if the point 2, 1 is a solution. And the way to tell is we substitute in the 2 for x and the 1 for y, but we've got to do it in both equations. We've got to make sure that it is true in both equations. Let me show you what I mean. In the first equation, when I put in 2 for x and 1 for y, I would get something like this. -3 times 2 plus 2 times 1 equals -4. Remember to use the order of operations to be able to simplify this so that you would get -6 plus 2, and that does equal -4. Then we do the same in the second equation. We substitute the 2 for x, the 1 for y. 2 plus 1 gives me 3. That's true. Because it's true in both equations, because we get the same number on both sides, then we know that yes, this is a solution, but it's only because both equations are true. Next, let's turn our attention to another method of solving 2 equations, a system of 2 equations, and that is the substitution method. I like to use this chart here just to kind of organize my work. So for the first column, you'll notice that I asked to solve for a single variable. Now, a single variable is a variable that has no number written in front of it. Like for instance, in the first equation, you have y equals 3x. Y is a single variable because there's no number written in front of it. So a lot of times the work's already done for us if we can identify that single variable. Now, in the second column, we're going to replace the y with a 3x, but we're going to do it in the second equation. So we're going to take that x plus y equals 8. I'm going to replace the y with a 3x. Now, when I do that, then the equation becomes very simple to solve, right? So I've got x plus 3x equals 8. That gives me 4x equals 8. Then you can divide both sides by 4, and I get that x is 2. So that substitution of the 3x in place of the y, then I can solve. All right, let's go to our third step then is now that we know that x is 2, we're going to replace the x with a 2. Now you can do this in either equation. I chose to use the x plus y equals 8 equation, and I replaced that x with a 2 so that I got y equals 6. So you can see I had to find both variables. I had to find out what x equals. I had to find out what y equals. And then I want to write my solution as an ordered pair. Remember, alphabetical order, x, then y. And so I get 2, 6 as my solution. Again, the chart's not really a big deal except that it helps me organize my process here. Let's take a look at one more example. Now, in this example, we want to focus in on the single variable, right? Remember, that's the variable without a number written in front of it. So we're going to be using that x in the second equation. But I have to get x by itself. I've got to move the 4y to the other side. So I'm going to subtract the 4y from both sides so that I can have x equals something else on the other side. And that leaves me with x equals 1 minus 4y. Okay, very important. Get that single variable by itself. We're going to replace the x with a 1 minus 4y, but we're going to do this in the first equation. So I've got 2x plus y equals 9. I'm going to replace the x with a 1 minus 4y. Be very careful here. I'm going to put it in parentheses. I need to because that 2 has to be distributed to both of the terms here. When I say distributed, that means I'm going to multiply 2 times 1, 2 times 4y. And that gives me 2 minus 8y plus y equals 9. Now I'm ready to solve. Let's combine the negative 8y plus y so that I get negative 7y plus 2 equals 9. And then I'm going to subtract 2 from both sides, trying to get that y by itself. That leaves me with negative 7 equals 7. And then I can divide both sides by negative 7 so that y equals negative 1. I found one of the values for the solution. Remember, it's not a complete solution until I have the values for both equations. So now we're going to replace the y with a negative 1. You can choose to do this in either of the equations. It doesn't matter which one. I chose the 2x plus y equals 9. So I'm going to replace the y here with a negative 1. And then I'm going to solve for x. So I'm going to add 1 to both sides. And that gives me 2x equals 10. And then I can divide both sides by 2. I'll get x equals 5. That's the other half of the solution. So remember, this is where I want to write it as an ordered pair. Think alphabetical order, x, then y. So I get 5, negative 1. So how'd you like that method? We've done 2 now. We've done graphing. We've done substitution. Our final one is called elimination. So the phrasing there. So the name of the method actually tells us what we're going to do. We're going to eliminate a variable. What you want to do is to look for the variable that has the opposite coefficients. When I say opposite, I mean same value. One's positive, one's negative. So when you look at these 2 equations here, you see that the y's have opposite coefficients. So when we do that, we are actually going to eliminate the y variable. And the way we do that is to add the two equations together. I want you to think about like terms though, because we're going to add the 5x and the 3x. We're going to add the negative y and the y. We're going to add the 12 and the 4. So that gives me 5x plus 3x is 8x. Negative y plus y eliminates y. Remember we said that's what we were trying to do. Gave me 0y equals 16. Now 0y, we don't have to write that. And so I get 8x equals 16. Or if you divide by the 8, you get x equals 2 here. This is the first half of the solution. Remember we talked about, got to have both variables in order to have the solution. So our next step, we got to go back and substitute. So we're going to take one of the equations, it doesn't matter which one, and we're going to substitute 2 for x. So I took the second equation, 3x plus y equals 4, and I put 2 in place of x. So now I've got 3 times 2 gives me 6 plus y equals 4, and I can subtract 6 from both sides. Y is negative 2. So that last step is the same for the substitution method as it is for the elimination method. But of course, we want to write our answer as an ordered pair, x, then y, alphabetical order, and I get 2, negative 2 as my solution. Remember, you're focusing in on the variable with the opposite coefficients, so you can eliminate it. So next, we begs the question, what if you don't have variables with opposite coefficients? Well, look at these two equations. You can see that we have the same coefficient in front of the c's. One is positive, the other's positive, but they're the same number. When this happens, we want to try to get them to be opposite. And the way to do that is to take one of the equations. In this case, I'm going to take the first equation and multiply by negative 1. In doing this, I'm creating that opposite. And I can multiply the first equation by negative 1 as long as I do it to every single term in the equation. So now I'm going to take the first equation I multiplied by negative 1. I'll leave the second equation alone because I don't need both of them to change. I just need one of them. Now we're ready to add the equations because we've got those opposite coefficients. So let's add those like terms, right? Negative 6c plus 6c, negative 7d plus negative 2d, and then of course on the other side I've got 15 plus 12. So that gives me 0c, I don't have to write it. Negative 7d plus negative 2d is negative 9d, and then of course 15 plus 12 gives me 27. So I've got negative 9d equals 27. So now I can divide both sides by negative 9. I get that d is negative 3. So when I don't have opposite coefficients, then I can multiply the equation by something to get them to be opposite. Now, I'm not done with my solution here. Remember, this is just half of it. So I'll need to go find the other half by substituting in negative 3 for d. Remember, you can do this in either equation. I generally will pick the equation that looks the easiest to me. This one did, the first equation. So I'm going to put in negative 3 for d. And then that 7 times negative 3 gives me negative 21. Now I'm ready to start moving things to the other side so that I get the c by itself. I'm going to add 21 to both sides so that I get 6c equals 6. And then I'll divide both sides by 6. I'll get c equals 1. Now remember, write your answer as an ordered pair in alphabetical order. So in this case, that would be 1, negative 3. That would be my solution here. All right, friends, let's do one more with this elimination method. And that is where you don't have any kind of same coefficient. What do you do then? If it doesn't have one that looks easier, you just need to choose one. So I'm going to choose A. I want to eliminate the variable A. Now, in order to eliminate A, I need them to have the opposite coefficients. So I'm thinking in my brain, what am I going to multiply that first equation by? What am I going to multiply that second equation by so that I can get those opposite coefficients? Well, I'm thinking of getting a 15 trying to get a 15 in front of that A. So I'm going to take the first equation and multiply by 5. That'll get me the 15 there in front of the A. And I'm going to take the second equation and I'll multiply by -3. And that'll get me the -15. So not only will I'll have the opposite thing that I need. So let's take a look at what that looks like. When I multiply the first equation by 5, I've got to multiply every term in that equation by the 5. I get 15a plus 20b equals 10. When I multiply the second equation by -3, I get -15a plus -27b equals -3. See, now I've got that opposite coefficient that I needed. So my next step then is let's go ahead and add the equations. Remember, think like terms. So you're adding the 15a plus -15a. You're adding the 20b plus the -27b. And of course, you're adding the 10 plus the -3 on the right side of the equation. That's going to give you 0a, don't have to write that in the future, plus -7b equals 7. And we can divide both sides by -7. That'll give me the b is -1. So if you don't have the opposite coefficients, you can multiply both equations by something in order to get those opposite coefficients. Now let's finish up by doing a little substituting. We're going to take the first equation, I'm going to substitute -1 for b so that we can find a, which would be the other half of the solution. So if we replace the b with a -1, that gives me 3a plus -4 equals 2. We'll add 4 to both sides so that we can move the 4 to the other side, and that gives me 3a equals 6. And then I'm going to divide both sides by 3 so that I get a is 2. Again, finally, I keep saying this, but we have to write it as an ordered pair. Make sure it's in alphabetical order. So I get 2, -1 there. So those are our 3 methods to use if we have 2 equations. We can graph it on the Desmos graphing calculator, link below in the description. We can do substitution, and we can do elimination. Each of them have their benefits. Some of them, like substitution, leans itself more when you have a single variable, so you'll want to look for that. Elimination lends itself more to when there's no single variables. It makes it a little easier that way. So I want to turn our focus then, and how do we do elimination method when we have 3 variables? So not just x and y, what about x, y, and z? So in order to do the elimination method with 3 variables, you need to rewrite the system into a system of 2 variables. That means you're going to eliminate one of the variables right from the beginning. So to do that, you're going to eliminate one of the variables and then solve the system that's left with 2 variables. You may be going, oh, this is many steps. It is, but we'll walk through an example with you, okay? After you do that, you're going to take the values you find in step 2 and put them in the original equation to go find that 3rd variable. Sorry about that. I had to move my video so you could see. Something to keep in mind here is if you obtain a false equation, something like 0 equals 1, 2 equals 4, then the system has no solution. However, if you find a true equation, 2 equals 2, -1 equals -1, 0 equals 0, then that means you have infinitely many solutions. So look for those 2 cases when the variables disappear. So for our system of 3 equations, 3 variables, let's use these 3 equations I have here. You'll notice I've written them and identified them as equation 1, equation 2, equation 3. This is going to help us remember which ones they are. But let's use these. So step 1, we're going to eliminate one of the variables in 2 of the original equations. For this, I've chosen equation 1, and I'm going to multiply 2 by equation 2. So what I'm trying to do is to eliminate that y variable. So I'm taking equation 1 as is, I'm taking equation 2 and multiplying it by 2. That gives me 4x minus 2y plus 6z equals 8. So I'm going to take equation 1, I'm going to add it to equation 2 here that I multiplied, And that gives me 7x plus 0y plus 10z equals 19. Again, I've eliminated the y variable here. And this I'm going to call the new equation 1. Some people like to call this equation 4. It's okay if you do. You just want to label it as a new equation that you're going to be working with when you come back to it. All right, now we're going to take and eliminate the same variable. Remember, we eliminated the y variable, but we've got to do it not in equation 1 and 2. We've already done those, but in 2 of the other equations. So I'm going to take equation 2 and multiply by -3. And then I'm going to add it to equation 3. So I used 1 and 2 and eliminated y. Now I'm going to take 2 and 3 and eliminate y. So if I multiply the equation 2 by -3, I get -6x plus 3y minus 9z equals -12. Now I'm ready to add this to equation 3. When I do, I get -x minus 4z equals -13. And I'm calling this the new equation 2. So we have a new equation 1 and a new equation 2. Now you'll notice I've eliminated the y variable first. So now I'm going to take my new equation 1, which was 10x plus, my new equation 1, which is 7x plus 10z equals 19, and my new equation 2, which is -7 minus 4z equals -13. And now I'm going to do elimination here. I'm going to leave equation 1 as is. I'm going to take equation 2 and multiply by 7. I'm trying to get rid of that x there. So now I can add the two equations together and I get -18z equals -72. I can divide both sides by -18. I get that z is 4. So remember what I did, I took 1 and 2, I eliminated the y's. Took 2 and 3, eliminated the y's. That gave me a new equation 1 and a new equation 2. And then I did elimination with those to get rid of one of the variables. In this case, I got rid of x. And that got me that z is 4. And that is not my whole solution. Remember, we got 3 variables here we got to find. So now we take z equals 4 and substitute it into either new equation 1 or new equation 2. So I'm going to take new equation 2, which was -x minus 4z equals -13, and I put in 4 for z. That gives me -x minus 16 equals -13. And I'm going to add 13 to both, I'm going to add 16 to both sides, divide by my -1, and then I've got x equals -3. So now I know z is 4. I know x is -3. My last step then is to go back to one of the original equations. Again, it doesn't matter which one you pick, but you want to substitute in -3 for x and 4 for z, and you're solving for y. Remember, that was the variable you eliminated at the very beginning. But you're going back to the original. So it's almost like you're taking the originals and you're going down to a new equation, 2 new equations, and you're solving for a variable. And then you're working your way back up in those equations until you have all 3 variables here. And because we found them, notice I'm putting them in alphabetical order in an ordered triple. So I've got -3, 2, and 4 as my solution here. Now, do not be overwhelmed by these set of 3 equations. They take practice, okay? Be very diligent about labeling your equations. Is this equation 1? Is this equation 2? Is this the new equation 1? New equation 2? Because when you look at your work, you will get confused which equation it is if you don't label them. So I always encourage labeling them. It's going to help you. Remember, practice makes progress. So the only way to get better at these types of problems is to practice them. Be sure to leave me a comment below if I can help or explain anything a different way. I'd be happy to help. Bye for now.